So let's solve this question. Consider the matrix 1 k 2 1 where k is positive real number. Which of the following eigenvectors are eigenvectors of this matrix? Okay, so let's solve. Given matrix is say M, for example 1 k 2 1, of course. Okay, so calculating eigenvalues, let's see, calculating eigenvalues 1 minus lambda k 2 1 minus lambda is equal to 0. This implies lambda minus 1 whole square is equal to 2k. So lambda is equal to 1 plus or minus square root of 2k. Okay, so this is what we have. So therefore lambda 1 is equal to 1 plus root 2k and lambda 2 is equal to 1 minus root 2k, of course. Now let's call the eigenvectors. So calculating eigenvectors, you can do this. Eigenvectors. Okay, so now if you calculate these eigenvectors, let's see. Yeah, for lambda 1 is equal to 1 plus root 2k, let's take initially. Okay, so 1 plus root 2k. So this implies 1 k 2 1 times x1 x2 is equal to 1 plus, or you can just multiply a1 equal to ax equal to lambda x. So x1 plus root 2k x1 x2 plus root 2k x2. This is what we have here. So if you simplify this, we have x1 plus k x2, 2x1 plus x2 is equal to x1 plus root 2k, this is x1, of course, root 2k x1, and this is x2 plus root 2k x2. This is what you have. So upon solving, let's see what you'll get. So if you solve this, we have k is equal to k x2 is equal to root 2k x1. So this ultimately gives you x2 is equal to root 2 by k x1, of course. Therefore x is equal to x1 x2 can be written as some scalar times of 1 and root 2 by k, of course. Okay, so 1 and root 2 by k. This is what we have here. Similarly, if you simplify this, you'll get 2x1 is equal to root 2k. So x2 equal to root 2 by k times x1, which is same as this. So 1 root 2 by k is one of the eigenvectors. So 1 root 2 by k. So this is basically an eigenvector, but not maybe we don't know. So let's see 1 and root 2 by k. So this term root 2k comma minus 1 root 2k comma 1, and if you take this root, if you just take this root k out, let's see what happens. If you want to take this root k by 2 by k outside, and if you want to keep 1 here, this can be written as root 2 by k x1, then this would give you root k by 2 and 1 here. Okay, so that we would have got, but it's not like root 2k, right? Yeah, this product will not be there, I guess, 2, and there is no minus sign, so it can be only both positive. So it's not root 2k, and this is not minus 1. So as of now, this gives only 1. So let's go to the other case. B, for lambda 2 is equal to 1 minus root 2k. Now what does this tell you? This implies x1 plus k x2 is equal to x1 minus root 2k x1 actually. Okay, so this is the equation. So ultimately this gives you x2 is equal to minus root 2 by k x1. That's what you'll get, right? x2 is equal to minus root 2 by k x1. So this implies eigenvector x1 x2 is equal to, if you take x1, we have 1 minus root 2 by k. That's it. Okay, so 1 minus root 2 by k. Therefore this eigenvector here in this case is 1 minus root 2 by k, of course. Okay, so 1 and minus root 2 by k, this option A is also correct, but C, D are wrong, because if you try to take this root 2 by k, you would have got root k by 2 but not 2k. So there is no chance that C comma D can be eigenvectors. So ultimately that A and B are the correct answers in this case ultimately. Thank you.